So now let's talk about how we actually come to tidy data, because now we know what we want to get the data sets that fulfill the three demands to tidy data. But now let's talk about how we actually get to this data. Recap again this quote of Hadley Wickham: tidy data sets are all alike, but every messy data set is messy on its own way. So that means that the starting point for data preparation is always different, because data that you download from the World Bank, from the internet, does look differently than data that you download from Eurostat. They are both messy, they do form a different starting point, but the goal is the same. You want to make both of these data sets tidy, and the good message here is that the steps to make the many different messy data sets tidy are usually the same, or more or less the same, in the sense that they refer to 6 main routines that you need to know. And while the sequence through which you apply these routines to the messy data set might be different from case to case, the routines as such do not change. So once you learn about these 6 main routines of data preparation, you are very well prepared to turn basically every messy data set into the tidy data set you need for your analysis. In this context, there are 2 main packages that we're about to use in the next minutes. First of all, the package tidyr that provides a number of functions for reshaping data into the tidy format. So that's really about data wrangling, in the sense that you take a messy data set, you change the form, you make it wider, you make it longer, etc., to make it tidy. The second package we're about to use is called dplyr, and that provides functions for manipulating data. So by this I mean, for example, creating new variables based on existing one, by renaming variables, or by summarizing the data by computing means, etc. So that's not data wrangling in the strict sense, but this idea of reshaping data and manipulating data is something that you usually do during the same period of time within your project. So I think it really makes sense to learn about reshaping and manipulating data within one consistent part of this course. They are, however, in some abstract way different, and therefore it also makes sense to put the functions into 2 different packages. But I would say 90% of the time you use both packages at the same instance, or at the same time. So yeah, let's turn into it and look at these 6 main routines that you actually need in practice. So what are these 6 routines of data preparation? Here we go through these 6 routines, and we then learn how to implement them in R afterwards. So this is about an overview. We come to implementation in a second. The first routine is to reshape data from long to wide format, and vice versa. What's long and wide format? It's not entirely perfect, this kind of classification. It's probably better to talk about rather long and rather wide data. By long or rather long data, I refer to data sets like this, where you have a lot of rows as compared to the columns, meaning that usually you have a column called variable, where all the variable names are in. And then you have a separate value for the columns, and that basically means that you have rather many rows as compared to the columns, because not each column refers to a particular variable or particular year. So that's a rather long data set, and you might often want to make it wider, in the sense that you turn it into something like this. Here you see now what has previously been in the column variable now refers to a separate column, and the values of the original column values are now allocated in these different columns, referring to the variable they are referring to. So shaping data from this long format to the wide format, and vice versa, that's usually called reshaping or data wrangling. And there are functions to do that. And this is something you will do many, many times in the context of data preparation. sometimes it's a little bit hard to wrap your head around in which sequence you need to make data longer or wider. So it's usually a good idea to actually write down the data set you want to get, compare it to what you have, and then think about, okay, in what sequence do I need to make this data longer or wider to actually reach my goal? But we will do that in the practices later on. The second routine that you use in data preparation, and here we are not talking about reshaping anymore, but about what I meant by manipulating data. So the second routine is filtering rows according to conditions. So think about, you have a data set that contains information about Germany and Austria, but you're actually only interested in information about Germany, so you want to filter out all the information about Austria. So in this case here, you need to filter out the first two rows of the upper data set to reach your goal, to get a data set where only information about Germany is included. So that's about filtering. Here you need to think about, how do I filter a data set using certain logical conditions. So in this case, the logical conditions would be the column C code needs to correspond to GE. Things like that. That's about the routine of filtering. So filtering is about reducing the number of rows. A separate routine refers to selecting. Here it's about reducing the number of columns. So in the upper data set, you see you have information for Austria and Germany on exports and unemployment. In case you're only interested in the exports, you might want to get rid of the column referring to unemployment data. So here it's really about selecting or deselecting columns and variables. In this case, you might want to deselect the column unemployment, or you want to select the columns C code year and exports. So selecting is in some sense the complement to filtering, only that selecting refers to select columns and filtering refers to filter rows. The next routine is called mutating, and that refers to changing existing variables or to adding new variables. The underlying functions are the same. So in this case here, in the upper data set, we have information about unemployment in the year 2013, 2014. We might want to have a new variable called change that actually corresponds to the difference between the value for 2013 and 2014. This is actually a nice example where you see, okay, maybe to reach the final data set you have, you might want to turn a messy data set into another messy data set, namely a data set where actually the columns refer to points of observation. Then you create a new variable that corresponds to changes, and then you make the data set tidy in the sense that in this case you remove the columns referring to the years. So that's what I said that that was what I meant when I say, okay, in the context of data preparation, you need to combine steps for wrangling data and manipulating data. So you might wrangle the data into a rather wide format from the beginning. Then you manipulate the data in the sense of computing new variables, and then you need to wrangle the data further to make it tidy. So it's usually not a good idea to start with a messy data set, make it tidy when you already know that you need to compute some variables for which you need to have the data set in a form that's not itself tidy. It's important that the data set is tidy in the very end, but intermediate steps might require a data set in a different form, as it's the case here. So to compute the change, you need to have the columns referring to the different points of time. And you do not have that in a tidy data set where you would have had a column referring to year and then the values in the different in this particular column. And it's much easier to compute changes if you have the years all having their own column. But aside from this, mutating in the sense of creating new variables or changing existing variables is actually rather straightforward. A little bit more difficult is the idea of grouping and summarizing data. It is, however, something that you usually do very, very frequently. So if you see at the upper data set, you have information for Germany and Austria referring to different points of time, namely the years 2013 and 14. Now think about the situation in which you want to have information about the average exports and the average unemployment over the whole time period. So in this case, you need to group the data and then compute averages for the different groups. So in this case, there are two groups, Germany and Austria, and you want to have the means or the averages of the two variables, exports, unemployment, for Austria and Germany. So you first need to group the data set according to the country code and then summarize it in the sense of computing averages of the two variables in this data set. So this is something, it's again a little bit more tricky in the sense that you need to think about the combination of grouping and summarizing actions, but it's something that you do very, very frequently in practice. Okay, and here's the next one, merging several data sets. The necessity of the routine stems from the fact that usually when you're interested in a particular research question, you need to combine data from different data sources. So in this case, think about you got information about exports from the, say, UN export database, and you got information about unemployment from the World Bank. And then you want to analyze the relationship between export activity and unemployment in the economy. So you would need to merge these two data sets into one so that you can work on this one to create a nice visualization relating exports to unemployment or do some data analysis. So merging several data sets is very important. It happens frequently. There are actually many different ways of how you can merge data sets with each other, but we will delve into this in a second. So to summarize, once you got your messy data from the real world, once you've imported it into R, then the next step is you need to make it tidy and you need to bring out the information you're interested in. And you can do this by a sequential combination of all the routines that I just mentioned: reshaping, mutating, filtering, grouping, summarizing, selecting, and merging. And what we do in the rest of this session is actually to learn how you can implement these routines in R. With these 6 routines, you can prepare almost any messy data set into a tidy data set that contains the information you want. In the end, you will have a data set that you can then use for visualization, modeling, etc. And you can do basically everything you want with the data set you get in the very end. There are some tasks for which you need additional functions, like especially when the cells do not refer to a single value. Then you also might need to unite or separate different columns, which is a little bit more tricky, but actually 90% of the tasks you can address with these routines. And to be honest, once you understand how these routines go, it's going to be very easy for you to actually just Google around and figure out how you can address the remaining 10% of challenges, which, as I said, in most of the cases do not occur. These 6 routines, and you're actually very good to go to prepare your data. And this will make you much more independent and able to analyze, to visualize, and to actually effectuate all your other data science skills that you acquired in this course. So yeah, let's turn into a practical implementation.